Good day, class. So this is the kanang last module for this course. We are now on series. So for this video, I'm going to discuss to you three topics. The first one is all about series. So can you see? And the next is arithmetic series, and finally binomial expansions. So let's start with series. So in this video, focus ta sa sa mga problems and questions para madali ta. And kanang basically when we say series class, these are um, collection of numbers arranged in a way nga naa sila'y kanang pattern ngayong makitaan. Let's say the second term maybe na-create siya by adding a certain constant on the first term. Let's say we have this series of numbers. Let's say a simple series of number 1, 2, 3, 4, and 5. So in order to determine the next term or the succeeding terms, we need to add 1 to the previous. Okay, so that 1 mo na siya nag-define sa value sa next term. And then ang series class, it is not only kanang limited to adding constant. You can also do subtracting a constant, or in other words, naakay operation diri okay, so meaning there is an operation that exists between these two numbers. Natay operation are, and this operation does not dili siya limited, does not limited to by adding a constant alone or subtracting a constant or multiplying a constant. You can have this operation into a mathematical expression. So let's say the governing equation, okay, the governing equation of these two numbers is this one, like x times x plus 2 all over 2, wherein x starts at 0, then 1, 2, and 3. So by substituting the value of x, then you can get the operation, and then after the operation, you're going to add that one to the previous term in order to get the next term, okay, or the succeeding term. So here, our first goal is to simplify some series equation. So I have here two examples. So this one, mo na siya nga itong gitawag nga mga operations nga ato i-add sa ato ang preceding term in order to get the next term. So these are the operations of our series. So we have here the direction, write the first 5 terms of the two series below. So assume that n starts at 1. Okay, so when we say a sub n, that is the that is the next term. Okay, that is the next term. So here, the 5 terms lang. So let's start with this one. The first one, this a sub n is equals to 6n 3n squared minus 1. So let's start with n equals 1. So that would be a sub 1 is equals to 6 times 1 all over 3 times 1 squared minus 1. So that would be equal to 6 all over 3 minus 1 is 2. So it would be equal to 3. Next, proceed ta sa n is equal to 2. So a sub 2 na to. A sub 2 na ni siya. Is equals to 6 times 2 all over 3 times 2 squared minus 1. Simplifying, we have 12 all over this one is 2 times 2, 4 times 3, 12 minus 1. So that would be equal to 12 all over 11. Okay, 12 over 11. Next, we have a sub 3. This is equal to 6 times 3 all over 3 times 3 squared minus 1. So that would be equal to 18 all over 3 times 3 is 9 times 3, 27 minus 1. So that would be 18 over 26, or i-reduce na to, magiging 9 all over 13. Okay, gi-divide na ako by 2. The next, proceed sa a sub 4. So we have a sub 4 is equals to 6 times 4 all over 3 times 4 squared minus 1. So this would become 24 all over 4 times 4 is 16. Then we have 16 times 3, 48. So we have here 48. So divide up it. 48, then minus 1. That would be 24 all over 47. So cannot be reduced na siya. And lastly, ang a sub 5, that would be 6 times 5 all over 3 times 5 squared minus 1. So this is 30 all over 5 times 5, 25 times 3, 75 minus 1. That would be 30 all over 74, or that would be equal to 15. And then 74 divided by 2, so we have 37. So we have 37. So now, our series is a collection of these numbers arranged from the first one, so that would be 3. Next is 12 over 11. Next is 9 all over 13. Next is 24 over 47. The next is 15 all over 37. So, by looking at the formula nga atong gigamit, we can say nga the operation that exists between these numbers is equal to the given expression. So that is, ang nag-exist nila, same na silang value, okay? Same na value ning nag-exist nila, which is equal to 6n all over 3n squared minus 1. So again, dili lang kay ang nag-exist sa nag-exist between the two elements on a series kay kanang kuan ra, constant ra. So it can also be an expression. So just like our example right now. So mo na siya na-exist between nila kay as you notice, kung simple subtraction lang between succeeding and the previous, wala tay pattern nga makitaan because ang pattern niya kay nag-govern day ani nga expression. 6n all over 3n squared minus 1. So, mo na siya ato ang kanang first 5 terms of our series. Okay, so next, we proceed to the next example. We have here a sub n is equals to negative 2 raised to n. So, taking the first term, so we have negative 2 raised to 1. So, that would be negative 2. Wait, ato siya along the first line. So that would be equal to negative 2. Next, a sub 2 is equals to negative 2 squared. That would be negative 2 times negative 2, positive 4. Next, a sub 3 is equals to negative 2 cubed. That would be negative 2 times negative 2, positive 4 times negative 2, that would be negative 8. The next, a sub 4 is equals to negative 2 raised to 4. So that would be negative 8 times negative 2, that would be positive 16. Next, a sub 5 is equals to negative 2 raised to the power of 5. That would be positive 16 times another negative 2. That would be negative 32. Okay, so therefore, ang ato dayang kanang series niya ni starts from 1. So we have negative 2, then 4, then we have negative 8, then we have 16, and we have negative 32. So the relationship or the operation that exists between the two numbers in the series are constant, and the constant there came from the expression, since namatay expression yung follow, came from the expression negative 2 raised to the power of n. So in order to get the succeeding term, you need to raise the constant negative 2 by the n, kung saan ay n niya. Let's say 2 ba, 3, or 4. So yun anara pag sa pattern sa atong series. Again, these are collection of numbers arranged in such a way nga na ay pattern or na relationship or na operation na exist between the two consecutive nga mga numbers. Okay, let's try the next one. So here, simplifying again. So let's try another. Let's say, assuming that n daw starts at 0. So sa previous, ang n kay nag-start ni 1. So how about kung mag-start ni 0? So uh, first 5 gihapon. So let's try this first expression. So we have here a sub 0 is equals to 2 minus 1 all over 3 raised to 0. So we all know that 3 raised to 0, that is equal to 1, di ba? 3 raised to 0 is equal to 1. So therefore, mahimo na siyang 2 minus 1, that would be equal to 1. A sub 1, we have 2 minus 1 all over 3 raised to 1. So that would be 2 minus 1 third. 2 minus 1 third. So we have here 2 minus 1 third. That would be 5 over 3. Or that would be 5 third. Next, a sub 2 is equals to 2 minus 1 all over 3 squared. That would be 2 minus 1 over 9. So we have here, we have 17 over 9. So we have here 17 over 9. The next, a sub 3 is equals to 2 minus 1 all over 3 cubed. That would be 2 minus 1 all over 27. So that would be equal to 53 over 27. So 53 all over 27. Next, we have a sub 4 is equals to 2 minus 1 all over 3 to the 4th. That would be 2 minus 1 all over, this is 81. So mahimo na ning 161 over 81. So we have here 161 all over 81. So until a sub 4 lang ta, nga naman, because starting from 0, it is already comprised of 5 terms, diba? 5 naman ni kabok. So hanggang a sub 4 lang. So therefore, our series for the first 5 terms are 1, then 5 third, we have 17 over 9, we have 53 over 27, then lastly 161 all over 81. So the governing operation between these two numbers, consecutive numbers, is 2 minus 1 over 3 raised to n. So minus that formula. Next, proceed to the second item. So we have here a sub n is equals to negative 1 raised to n all over n squared. So starting with a sub 0, we have negative 1 raised to 0 all over 0 squared. So this one, any number raised to 0, the answer is 1. Then here, kanisha is 0 squared, 0, so therefore this is undefined. Meaning, dili pwede ang 0 di ay ani nga series, or that would be infinity, clear undefined. So meaning, even if natay series, nagya po na yung mga restrictions. So here, ato nakita na restriction nga, sa n should not be equal to 0, kay wala tay value sa ato ang series. We cannot have the value infinity. So, proceed na a sub 1, so that would be negative 1 raised to 1 all over 1 squared. So this would be negative 1 all over 1, that would be negative 1. Next, we have a sub 2, negative 1 squared all over 2 squared, so that would be 1 all over 4, so 1/4. Next, a sub 3, we have negative 1 cubed all over 3 squared. So we have here negative gihapon kay even add man ang 3. So add man si 3, we now have negative 1 all over 3 times 3, 9. So that would be negative 1 over 9. A sub 4, the last one. So we have here negative 1 raised to 4 all over 4 squared. So that would be equal to positive na siya kay even man ang exponent. So 4 squared is 16. So we have 1 all over 16. So therefore, ang ato ang first 5 terms sa atong series governed by this operation, negative 1 raised to n all over n squared, is the first one is undefined, so meaning we don't have value for n is equals to 0. Next we have negative 1. Next we have 1/4. Next we have negative 1 over 9. Then lastly we have 1 over 16. Okay, so muna to ang series. 5 terms. Wherein ang first term at n equals to 0 kay undefined siya. Based sa atong calculation. Okay, so yun na pag-simplify sa atong mga series. Next, proceed ta sa pattern recognition. So, when you say pattern recognition, inverse ni siya sa atong gibuhat kiniha. Kaganiha, gihatagan ta og kanang formula or operations sa atong series. But this time, how about if we do the reverse? Like, hatagan na punta sa atong series, din pangitaw na to ang pattern nga nag-exist nila or ang equation or operation nga nag-govern nila. So, here, we have write an expression daw of the apparent nth term of the sequence. So this is example of a sequence or series. Assume that n begins with 1. So here, when we say assume n begins with 1, meaning sa ato punya pohon nga kanang equation, dapat it involves the n variable such that n starts at 1. So when you're going to substitute n is equals to 1, you will get the first term. At n is equals to 2, you will get the second. N is equals to 3, the third, fourth, so on and so forth. So how are we going to generate a formula, okay, or a relationship between the succeeding succeeding mga terms? So here, let's just list this one again. So we have 1, 4, 7, 10, and 13. So ako siya gilayo para ato maklaro. So first thing to know the pattern class is the basic. Ang basic is you're going to divide, maybe ang ilahang difference is constant. So let's try. So we have 4 minus 1, we have that one 3. Then 7 minus 4 we have 3. 10 minus 7 we have 3, and then 13 minus 10 we have 3. So therefore they have a constant they have a constant difference. So meaning in order to get the next term, you should add 3 to the previous term. So therefore, unsa man nato pagka-derive sa formula? So we have here a sub n. Before that, let's say a list. So that is for a sub 1. So we have here a sub 1. That would be equal to 1, right? This is the first term. To get the second term, that is a sub 2 is equals to the a sub 1 plus 3, diba? And then in order to get the a sub 3, that is just equal to a sub 2 plus 3, or in other words, equal na siya ni a sub 1 plus 3 plus 3. Next, for a sub 4, so we have a sub 3 plus 3, but a sub 3 is equal to a sub 1 plus 3 plus 3, then plus pa yun aning 3. Okay, kaning last. So therefore, by looking at the number 3, kapila siya nag-repeat according to the order of the series. So sinote sa circlean, kung 2 ni siya ang mag-add ta og 3 kay kausa. When kung usa siya, wa tay ma-add nga 3. So sa kay indication na. And kung motulo pud siya, ang gi-add nato nga 3 kay 2. Kung upat siya, ang gi-add nato kay 3. So therefore, ang atong gi-add, ang number sa atong gi-add kay equal to the n, okay? That is equal to the n minus 1. Nga naman, when our n is equals to 3, so to check ha, when n is equals to 3, so the number of 3 here na to i-add is that is 3 minus 1 is 2. So that's why we have 2, 3 here. So therefore, ang kaning expression nga n minus 1, we also need to multiply this by the constant nga nag-operate nila. So the constant here is 3. Or we call this in arithmetic, that is the common difference. So therefore, in order to solve for a sub n, okay, a sub n, we just write simply a sub n is equals to the a sub 1 kaya ang a sub 1 na aman if we're going to continue this up to any values of n, so we can arrive a pattern that a sub n is equals to the a sub 1 plus this one, the kanang difference among the terms, that is 3, multiplied by the governing equation for the kanang additional 3 kay diri di ba si 3 usara kung duha siya, kung a sub 3 siya duha, a sub 4 tulo, so that is n minus 1. So we have here n minus 1. Substituting, so we have here a sub n is equals to a sub 1 here is 1 plus the common difference is 3 man, so 3n minus 3, that would be a sub n is equals to 3n minus 2. So if we're going to check, so at n is equals to 1, so that would be 3 times 1 minus 2, so that is 3 minus 2, that is 1, so correct. That is at n is equals to 2, so that would be 3 times 2 minus 2, so that is 6 minus 2, that is 4. So therefore our second term is correct. Now how about the third? That is at n is equals to 3, so we have 3 times 3 minus 2, so we have 9 minus 2, that is 7. So therefore sakto gyud gihapon siya. So since almost sakto naman gyud siya, so therefore ang ato ang governing equation day for this series is kani siya. We have a sub n is equals to 3n minus 2. So mana siya ang operation nga nag-exist between the two numbers on the series. A sub n is equals to 3n minus 2. So again, this is a reverse kay atong gikuha diri ang formula nga nag-exist between the given series. So yung siya yung naon. Ayun kitaan ko na kay pattern nga makit-an. So next here, ang goal na today is find out the next term of the series below. So what would be its next term, or kato na iphon, that would be first, second, third, fourth, fifth, sixth. So ika-sixth nga term ang missing mo na itong ipakitaan, since that is the next term. So in order to solve for this, again, gamiton nato initially ang ato ang knowledge so far sa pattern recognition. So this 1, 2, 10, then 19, then 23. Okay, fundamental nga bahatan is by taking the difference of the next term minus the previous. That would, this one is 2 minus 1 is 1, 10 minus 2 is 8, 19 minus 10 is 9, then 23 minus 19, that is 4. Okay, so after this, since unlike sa ato ang first example nga constant man iyahang difference, here not constant, na 1, na 8, 9, 4. So if we're going to take the third na pod nga, second nga subtraction silang duha, this one is 7, this one is 1, then this one is 4 minus 9, that is negative 5, right? So here 7, 1, negative 5, wala gyapon siya distinct nga pattern. So therefore maybe there is another kanang relation na exist aning 1, 8, 9, and 4. So here kung yung napansin, magsuwat ta, si 8 si 9 is a perfect square, diba? Perfect square na siya. Si 8 kay perfect cube po na siya in terms of 2. Si 9 kay perfect square in terms of 3. Si 4 is kanang perfect square po. So if we're going to let this one as x cube, wherein my x here is equals to 2. So this x is equals to 2. I have here 8. Then here po, we have here x squared is equals to 9, wherein our x here is equals to 3. So I have 9. Here, mura na kog na naka idea nga, oy, x3 and then x2. So possibly this would be x4. Okay, this would be x4. So since sinotis pud sa atong value sa x 2 3 pud, so therefore maybe this one is equals to 1. Okay, pasunod ba 1 2 3. So x equals to 1, so that is 1 raised to 4 is still 1. So sakto siya na sense. Next, ang 4, this is 2, so maybe x1 na siya. X raised to 1. Then here, since this is 3, so every x equals to 4. So here, 4 raised to 1 is 4. So therefore, nakuha siya. So, since nakaget na ta sa iya pattern, we can now predict the next term. Okay? Makapredict na ta sa next term. Sa to ang kanang series. So, ato siya erase. So, ang next term would be kani siya, ang governed dira is this is x raised to 0, and that would be x is equals to 5. So 5 raised to 0 or any number raised to 0, the answer is 1 gihapon. So it would be 1. So therefore 23 plus 1, that would be 24. So therefore, kung ato nakita, the sixth term of this series that has a unique pattern is equal to 24. So man siya. So dapat practice gid og pangita og pattern sa ato series. So the answer is 24. So next, proceed ta sa simplifying factorial. Okay, but before simplifying, ato sa kanon ko unsa ni ang factorial class. Well, ang basic na concept sa factorial is that if we're going to take the factorial of a number, so let's say we have here 5 factorial. Ang atang 5 factorial, that is just equal to the product of the number 5 multiplied by the number nga gibanan nimo og 5 minus 1. So meaning decreasing, that would be 5 times 4. Then ibanan na pud nimo ang 4 og 1, that would be 3. Then 2 and then 1. So that is equal to 5 times 4, 20 times 3, 60 times 2, 120 times 1. So 120 rin siya. Then if you also have 6 factorial, so magiging kuan gyapon 6 times 5 times 400 times 1. So we have 120 times 6, that is 720. And if you have 1 factorial, that is just equal to 1. And note, special case for factorial, if we have 0 factorial, the answer is 1. You can watch some videos to prove nga 0 factorial is equals to 1. And then, if we're going to write the generalized formula for factorial, let's say if we have n as a number, so that would be n factorial. What is its formula? We're going to take the factorial of a certain number n, so that would be the number n muna multiplied by n minus 1, meaning bawasan nato kay diba 5 then gibawasan himong 4 times n minus 2 na po ang gibawas ngano man na nakakatag 3 di 4 5. The next is n minus 3 hanggang maabot siya og 1. Okay, so that is the kanang general formula for the factorial of a kanang certain number. Okay, so siya. Okay, so we're going to simplify this kaning factorial nga expression. So let's start with the first one. So we have here 4 factorial over 6 factorial. So 4 factorial all over 6 factorial. So again, ato itong gamitin ang formula for factorial. That would be, if we have n factorial, we have n times, ato subtrakan og usa, n minus 1, then multiplied by n minus 2, n minus 3, hanggang mahimo na, hanggang ang last kay 1. So 4 factorial, we have 4 times, minus na natog 1, we have 3, times minus na natog 2, matuo na lang, times minus na to og 3, that would be 1. So since na 1 naman, so stop na. Then for 6, we have 6 times 5 times 4 times 3 times 2 times 1. So here, na common para madali ta na may common, di ba? 4 times 3 times 2 times 1 mapuna sa numerator. So therefore, mawala na nga operation. Okay? So what's next? May mo na siya og 1 all over. Nabili na lang sa ubos is 6 times 5. So that would be 1 all over 30. So inganaon pag simplify og kanang factorial nga expression. So the answer here is 1 all over 30. So let's try the second example. So we have here n plus 1 factorial all over n factorial. So kaya siya naglibog mo, siguro maglibog mo unsa ani pag-simplify. So just follow the kanang formula. So here ato siya i-considered nga ang n plus 1 is a single unit. So just follow this pattern. So to simplify this, ang numerator mahimo na ning ang number so that would be n plus 1. Next is ato siya i-subtract by 1, so magiging n na lang, di ba? Kay n plus 1 minus 1, that would be n. Next, ato subtrakan og minus 2, so that would be n plus 1 minus 2, that would be n minus 1. Then next is n minus 2, kay that is n plus 1 minus 3, n minus 2 man. Hanggang mahimo na lang siya og 1 all over this n. Again, just write this, okay? Ato na siya is what? So that would be for n factorial, starts with n followed by n minus 1. Next is n minus 2 hanggang ma-equal na siya to 1. So as you notice, na ay factor nga common sa both numerator and the denominator. That is, nag-start sa n padung sa 1 and also in the denominator n padung sa 1. So therefore, what's left is n plus 1 na lang. So that would be equal to n plus 1. So this is the simplified form of our given. Now, to prove this, nganong n plus 1 na lang, let's say we have n, okay, to verify, let's say we're going to let n is equals to 5. So it would now become 5 plus 1 factorial all over 5 factorial, and that would be 6 factorial all over 5 factorial. So 6 factorial can be written as 6 times 5 pa-decrease, 4 times 3 times 2 times 1. 5 is 5 times 4 times 3 times 2 times 1. So therefore, makancel na ni siya. Makancel po ni siya. So therefore, ang nabilin kay 6 na lang. So this one is equal to 6. And if we're going to use our kanang equation na ito nakuha, that is n plus 1. Ang shortcut ng n plus 1, so that would be n here is 5, so the n plus 1, so that would be 5 plus 1, that is equal to 6. So therefore, they have the same answer. So na-verify nga sakto ato pag simplify sa atong given nga kanang factorial expression. So ingana ra pag simplify og mga factorial expression class. Next, proceed ta sa writing sigma notation. So when we say sigma notation class, mo na siya ang ato ang abbreviation para dili ta magsuwat og kanang lista sa ato ang mga kanang series of numbers. Okay, mao ni ang shortcut sa pagsuwat. So ang sigma notation na dako nga sigma gidenote siya, dako nga sigma kani siya, and then after the sigma magbutang ka diri og kanang mathematical expression. So meaning sa series pa dira ang imuhang operation nga nag-govern between the successive nga mga numbers. The next sa sigma notation na adre imuhang control parameter, that is from I starts. So muna siya ang starting value. I is equal to the starting value And then the upper part of the sigma notation, this is the kanang kuan, the ending value kung asa, or the terminating value. And this I here, kung sa imong gi-initialize abos, this should be seen, or this should be written on the mathematical expression. So if we have an example, so we have an example sigma notation. Let's say sigma, meaning mo na yung sigma, that is the sum. Okay, sigma sum na siya, nagdenote siya sum, meaning ang ato ang numbers arranged in series, ato na siya i-add. So mana siya ang sigma notation. It denotes the sum of the numbers in series. So sigma notation of simply I plus 1 lang. So I plus 1 is our mathematical expression for our sigma. And then I down nato nag-start ni 1 hanggang 5. So if we're going to expand this class, if we're going to expand this sigma notation, what you need to do is this mathematical expression is mo na siya substitute, that is I starts at 1, so that is I is equals to 1, so that would be 1 plus 1 plus I is equals to 2 na pod, that would be 2 plus 1, di ba? Kaya naman I plus 1 man. The next I is equals to 3, so we have here 3 plus 1, then plus I is equals to 4, so we have here 4 plus 1. Since yung siya nga I is hanggang 5, so again ang 5 ang kaning location sa babaw, nagdenote na siya sa ending value sa ato ang parameter I. So that is plus, at I is equals to 5, that would be 5 plus 1. So simplifying, this would be, the first is 2 plus 3 plus 4 plus 5 plus 6. So the summation of this expression is equals to, this is 10, 15, 16, 17, 18, 19, 20. So therefore, the value here for this summation nga notation is equals to 20. So nga na pag denote og summation, manay ang parte, manay nyo yung dapat tigaman. Again, I is the parameter and it should be included on the mathematical expression. So I, parameter and a variable. Then ang number nga located at the top, that would be your terminating value, or the last value, or the ending value. And kung makita ka mong summation nga notation, ano siya, nagpasabot na siya nga that is a series of numbers nga mo siya i-add. Okay, so just like here in our example, so notice series siya sa number, then na ay operation nga addition. So that's why pwede ta makaswat sa iyang sigma notation. So in writing this sigma notation, marsag pareho sa ato ang pattern recognition. Let's say we're going to compare the numbers in the series, each numbers here. So let's say unsa may nagka-diferensya aning duha ka mga numbers. Let's say here the first term 1/3 divided by 1. Sa next na pod 1/3 divided by 2. Next 1/3 divided by 3. So ato nakitaan nga, uy, mura siya og divide og number but nag-increase by 1. Right? Kaya nagsugod mo siya sa 1, then plus na po og 1, ang next is gi-divide na po siya by 2. Plus na po 1, mo ang next gi-divide by 3 hanggang divide by 9. So until 9 lang ang summation. That's why we have a terminating value for our parameter. So here we're going to write the sigma notation. So sigma notation, then you're going to put the expression that governs our series. So here I'm going to write 1/3. And the next 1 divided by we're going to use I as our parameter. So that is ang governing principle nga behind aning 1, 2, 3, that is equal to I minus 1 lang. Okay, kaya ang difference anak nila, difference sa 2 and 1 is 1 man. So that's why I have I minus 1. And then close. And then I should start at 1, ends at ilan. So since 9 man, so we're going to end 10. Why? Because if we're going to substitute I is equals to 10 here, so that is 10 minus 1, that is 9. So therefore 9. We cannot do 9 because if we're going to substitute that one sa ato adring expression, that it will be 9 minus 1, that is 8. So dapat lapasag usa kay nag-subtract man tag 1 area. Okay? And to check this, so we can also further simplify this. Sigma notation, I is equals to 1 hanggang 10. So that would be 1 over 3 I minus 1. So to verify this, ito ang kanang kuan ato ang formula. So that would be I is equals to 1. So that would be 1/3 all over 1 minus 1. Okay. I think we need to kuan na yan because 1 minus 1 is kanang 0. So I think we need to start at kuan. Dito pwede mag-start sa 1 because it will make our expression undefined. So dili pwede. So what we need to do here is ato na siya ikuan. Ato i-change. So si I di mag-start ni 1, but in order to get 1, so ato siya kuanan og kanang kuan. That would be n minus 1. Okay, so may mo siya og ila difference is kuan man kanang 1 raman. So that would be 1 plus n minus 1. So n ra basically n ra di ay or I. So naglisod-lisod pa ta. Okay, 1 raman. So that is just equal to 1 all over 3 I ra. Oh, maraday na siya. So sorry ganiya. So to prove this, so 1 all over 3i. So at I is equals to 1, so we have 1/3 times 1, so that would be 1/3. So same na sa tong kan. The next, I is equals to 2, so we have 1/3 times 2. So that's why we have 6, or 3 times 2, 6. So therefore, ang ato ang answer ni so yung sigma notation is this one. I mean, di na siya mag-end og 10, but 9. So, kanina siya diri, hanggang 9 na ni siya. Okay, so proceed ta sa next. Here, next nato is, natay duha ka, natay duha ni ka kitaon nga parameters. Okay, so ito na siya erase. Diri ang terms nga nasa ato series kay 3 minus 9, next is 27 minus 81, next is 243 minus 72. So let's start with 3 minus 9. I mean, let's start with the first number. So as you notice, kada first number nila 3, okay, kaning 3, 27 and 243 actually nag-govern nila nga equation. So kung nyo makita, ang nag-govern nila is this one is 3 raised to 1, this one is 3 raised to cube, this one is 3 raised to 5. So kung nyo simplify, 243 ang answer niya. So notice, ang yung exponent is an odd number. That is, starts from 1, then 3 and 5. Or ang ilang common difference is 2. Diba? 1 plus 2 is 3, 3 plus 2 is 5. So, nanatay pattern for the first number. How about for the second number? Can you see, kaning 9, 81, and 729. So, 9, okay, 9 can be 9 raised to 1, that's equals to 9. Diri 9 raised to 2, 81 gapon. Ang 729 is 9 raised to 3. So, to prove that, ang calculator, 9 raised to 3, that is equal to 729. So, therefore, sa second number, ang yung exponent kay naka-arrange into 1, 2, 3, or naka-integer siya, pasunod. Whereas sa first number is pa-add, I mean, mga set of odd numbers. So, in order to formulate that one into a single term, I mean, into a single parameter, sa ilahang exponent, So naata diri governing operation. So ang ato ang governing operation nag-start siya ni 3. So it will be 3, and then ang common difference nila is kanang kuan man no. Common difference nila is kanang 2. Okay? So ang ato diri is 2n or 2i day. 2i minus 1. So let's check. If I is equals to 1, that will be 2 times 1 is 2 minus 1, that will be equal to 1. If I is equals to 3, if I is equals to 2, that is 2 times 2, 4 minus 1 is 3. So therefore, na-check ni ang 3. If I is equals to 3, the third term, that would be 2 times 3, 6 minus 1, 5. So therefore, nakuha niya ito ang exponent nga 5. Okay, then minus 9 raised to I lang. Okay, kay that is, if I is equals to 1, that is 9 raised to 1, makuha na ito ang first term. If I is equals to 2, 9 raised to 2, makuha ang second, so on and so forth. So therefore, this is the mathematical operation for our summation. So by adding summation, and then I, our parameter, is equals to, nag-start siya sa, asa man start siya sa 1, then may end siya sa, since tulo naman ni ka-term, so we have here 3. Okay, so yung substitute balik dira sa ato ang summation nga notation, then maka-arrive ka ni nga series, the sum of this series. Okay, so yan na siya class pagkuha class. Try to determine the pattern behind these numbers. So next, we have here writing the partial sum. So again, partial sum included gyapon na siya sa summation kay naman tayo gitawag nga infinite series. So kung infinite series walay humanan. So mao na ang partial sum. Mao na siya ang sum nga naa siya kanang finite number of kanang number of terms. So here, di ba ang madri, I is from 1 hanggang infinity. So since kay partial sum naman itong ipangita mo nang indicate sa direction, we're just going to write the sum of the of the 4 terms here. So hanggang 4 lang ta diri So that is ato butang, that is I is from 1 hanggang 4. So ato summation of 5 1/2 raised to I. So ano ni siya kani? Ito ni hawaon. And then I starts from 1 hanggang 4 lang kay 4 partial sum man. So that is start ni 1, so that is 5 1/2 raised to 1 plus 5 1/2 squared plus 5 1/2 cube plus 5 1/2 fourth plus 5 1/2 fifth. So the first one is 5 halves. Second is 5 over 2 times 2 4. Next is 5 all over 8. Next is 5 all over 16. Next is 5 all over 32. So simplifying this, naatay 5 halves plus natay 5 over 2, 5 over 4, then plus 5 all over 8, then plus 5 all over 16, plus 5 over 32. So we have 155 over 32. So the sum is 155 all over 32. This is the value of the fourth partial sum of our infinite series. Again, infinite series ni siya, infinite series kay infinity man ayahang ending, meaning way kahumanan, infinity. So next here, write the third partial sum na pod. So that is I from 1 hanggang 3 lang. So that is summation of the governing operation 4 times 1 negative 1 half raised to n such that n is equals to 1 hanggang 3 lang. Executing this, so we have 4 times negative 1 half raised to 1 plus 4 times negative 1 half squared plus 4 times negative 1 half cube. So diri this is negative 4 all over 2. Then this one mas square naman is mo positive na, so that is plus 4 all over 4. Then diri cube man ni negative gihapon, that is minus 4 all over 8. So simplifying further, we have negative 2 plus 1, then negative 1 half. So the answer here, this one is negative 1 minus 1 half, so that would be negative 3 halves. So we have here negative 3 halves. So the answer for the third partial sum is equals to negative 3 halves. Okay, so let's proceed to the next. Nata diri sa kanata, arithmetic series. Okay, naata sa second topic about arithmetic series. Okay, so nanata sa arithmetic series. So kani siyang arithmetic series, special ni siya, special type of series wherein the operation or the relationship that exists between two succeeding terms is equal to a constant, or kanang constant gitawag siya nga common difference. Let's say we have here a series of numbers that is 2, 4, 6, 8, 10. So as you notice, ang relationship between 2 and 4, that is in order to get or in order to solve for the number 4, we should add the previous term 2 by 2, di ba? Kaya ang difference sa 4 og 2 kay 2 man. And then on the next term pod, 2 gihapon diri kay 4 plus 2 is 6. Next 6 plus 8 is 2. Then 8 plus 2 is 10. Okay. So if their difference is constant, so naa sila'y kanang constant nga difference, kana siya nga series or sequence is arithmetic. Okay, may si arithmetic magud nag-add tag something, and then the constant difference pod class, it could either be negative or positive. So if ang ilang common difference kay ang kani pod ilahang difference gitawag po ni sa arithmetic og common difference. Common difference denoted by D. Okay, so we're going to derive ang general formula in order to write for the nth term of our arithmetic series. So here, naa sila common difference, so constant siya. So if ever dili na gani constant, so that series is not an arithmetic series anymore. So lahi na po na siya nga series. Basta for arithmetic, constant ang ilahang difference, or gitawag natin siya nga common difference. So based on our example here, 2, 4, 6, 8, and 10, how are we going to write a formula in order to find for the nth term? Let's say that the 56th term, so on and so forth. So in order to solve for that, again, we apply na pod sa aning usa ka parameter n. So n, this one will keep track to the number of terms for our arithmetic series. So here we denote that 2 here is n here is equals to 1, then n here is equals to 2 for 4, then 3, this is 3, the third term, then the fourth term, and the fifth term. So that would keep track to the kanang kuan, to the placement of our numbers n. So here we're going to let a, that is the kung siya nag-represent sa ato ang kuan, sa ato ang term. So that is at a sub 1, we have there 2. Next, at a sub 2, naapod tayo 4, but in order to solve for 4, that is just equal to a sub 1 plus the difference of 2, diba? Ilahang constant difference or common difference 2. Next, at a sub 3, that is just equal to a sub 2 na pod plus 2. Or in other words, that is, ang a sub 2 na pod kay a sub 1 man. A sub 1 plus 2 plus 2. Okay? Next na pod, at a sub 4, that will be equal to a sub 3 plus 2. But since, kay bawa naman ni a sub 3, in terms of a sub 1, that is a sub 1 plus 2 plus 2 plus sa 2 diri that is plus 2. So therefore, if we're going to simplify this, bisag kanilang a sub 2 to a sub 4, natin mo ko nga kani siya, this is a sub 1 plus 2, kani siya is a sub 1 plus 4, and then we have a sub 1 plus 6. As you notice, naatay pattern yung nag-exist pod between this number right here and this number here. Kani siya. And then of course this one 4 and then this one. So sa kay nag-exist sa nila. Si 4 at 4 nagiging 3. Then si 6 at 6 nagiging 4 na pud siya. Or ato kitaon how many kanang kuan, how many number of kanang 2 ang naa nila. So at a sub 2 pila ka numbers 2, that is 1. At a sub 3 na ay duha ka numbers 2. At a sub 4 na ay 3. So therefore, ang number of kanang 2 here, since ang 2 is a significant number, 2 there is our common difference D. So di ba? Our common difference denoted by D is equals to 2. So that's why significant na siya nga number. So 2. So therefore, ang multiplier sa kada term nato diri is nag-agad siya sa number of terms, I mean the nth term, that is 3 minus 1 kay kung naata sa a sub 3, ang atong multiplier is 2 man. Kung naata na a sub 4, ang atong multiplier kay 3. So therefore, kani siyang last column diri aya di formula diri is the common difference D minus n minus 1, di ba? Mura man nila. Kay kung ato difference kay 2, then ato ang n kay 3, that is 2 times 3 minus 1 is 2. So 2 times 2 is 4. That's why nakuha itong 4, nakuha po ni 6. So therefore, out from this kanang kuan, ato na-generate yung mga kanang statements, makaingon ta nga, to solve for a sub n, just write a sub 1. Kay kani siya nga pattern mo continue magini siya nga a sub 1 gihapon plus d times n minus 1. So that is a sub n is equals to a sub 1 plus n minus 1 times d. So inganaw na day pag solve og arithmetic series for an n term. Let's say pangitawon ka sa 6 term, mo na mo gamiton, that is imara suwat nga si a sub 6 is equals to a sub 1 plus 6 minus 1 times ilahang common difference d. So again, to solve day for arithmetic, you should know how to define the first term, the number of terms nga na-involve o iyang ilahang common difference in order to solve for the next term or a certain term nga required sa question. So mara na siya ang sa arithmetic, and later on sa mga examples ato pod mangitaon ang sum sa aning arithmetic nga series. Makuha gyapon na to, nagyapon na siya formula. But for the meantime, again, mao na iya general formula to solve for the nth term of our arithmetic series, that is a sub n is equals to a sub 1 plus n minus 1 times d. At utrohon kina natabunan man a sub 1 is equals to a sub 1 plus n minus 1 times d. Mana siya. So here, nata example, write the first 5 terms daw. So first 5 terms daw. Diri a sub 1 is equals to 5. So here a sub 1, take on diri a sub 1 is equals to 5. That is our n here is equals to 5 kay first 5 terms man. So that is a sub 2 is equals to, since we're given common difference class 6. So what we need to do is just add 5, kaya naman tayo a sub 1, just add 5 by 6. Or you can also use this general a sub n. So kung ato na gamito ning general formula, that is a sub 1 plus, since our n here is 2, napman ta sa 2, that is 2 minus 1 times the d here is 6. So that would be 5 plus 1 times 6. So that's why yung ganiha, just add na lang. 5 plus 6, that is 11. A sub 3 is just equal to a sub 2 plus the difference, okay? A sub 2 plus the difference, that is equal to 17. Or you can still use the formula, pareha slag kuha. For a sub 3, that is equal to a sub 4 rin eh. A sub 4, that is a sub 3 plus the difference. So we have 17 plus 6, so that would be equal to 23. Okay. Next, a sub 5, the last, is equal to a sub 4 plus d. So natay a sub 4, 23 plus 6. So we have here 29. So therefore, our arithmetic series is nag-start siya sa 5, next is 6, the third is 11, ay no, why labot ang 6 diri 5, 11 na. So 5, 11, then 17, and then 23, and then 29. So, kung yung pangita ng difference nila, musakto gid sa d is equals to 6. Okay? So, muna siya pagsuwat og mga terms sa arithmetic series. So, you can use the formula nga akong giderive ganiha. A sub n is equals to a sub 1 plus n minus 1 times d. Next, how about if we have a sub 8 daw, and then a sub 12. But here, our goal nato based on the direction is writing a sub 1 hanggang a sub 5. Well, the given here is a sub 8 manog a sub 12. How are we going to solve for this? So again, in order to solve for a sub 1 and a sub 5, dapat kay bawta sa difference. Magana importante. Okay? So, diri ato na gamiton niya ang general formula. Well, kung ato balikon diri kanin siya ato ang formula kaning diri sa ubos. This is if it starts manoon. So, it starts na siya. If it starts at 1. How about kung wa siya nag-start sa 1? Unsa ito formula ni ini? So the general formula gid para sa tanan nga mo-apply ni siya. So that is a sub n is equals to a sub k plus n minus k times d. Magani siya class. Let's say your n is 20, then your k, so n is equals to 20, k is equals to 11. So therefore, your formula should be a sub 20 is equals to a sub 11 plus 20 minus 11 times d. And then solve for this. So, kani siya, magini pinaka-generalize nga formula. So, kung mag-start siya 1, so ilit nimo k is equals to 1. Generalized formula for your arithmetic. Okay, so we're going to use that kanang general nga formula for arithmetic. So, here, para ma-solve na to si d. So, that is n is equals to 12, then let k is equals to 8. So, that from the general formula, we have a sub n is equals to a sub k plus n minus k times d. So, to solve for d that would be d is equals to a sub n minus a sub k all over n minus k. So, here, a sub n nato is that is a sub 12 minus a sub k nato is a sub 8 all over 12 minus 8. So that would be a sub 12 is 42 minus a sub 8 is 26 all over 12 minus 8, that is 4. So therefore our common difference is 42 minus 26 divided by 4. So the answer here is 4. So therefore nanatay common difference. So what we need to do here is to solve for a sub 1 hanggang a sub 5. Now, to solve for a sub 1, kay mo na importante. Saan ka na to pagkuha? Now, you can pair, okay? You can pair this. Let's say, i-pair nimo si a sub 1 hanggang a sub 8. Kay mo may given. And then, kay ba naman nga natay d. So, makakuha na ta sa iyahang kanang a sub 1. Ato i-let, okay, we're going to let again, n is equals to 8. Our k starts at 1, kay a sub 1 man. Our d here, nakakuha naman tag d ani, that is 4. So, we're going to solve for a sub 1. So, mahimo ni siya og a sub 8 is equals to a sub 1 plus 8 minus 1, kay n minus k man, times the d is 4. So, solving for a sub 1, we have a sub 1 is equals to a sub 8 minus 8 minus 1 times d. So, a sub 8 here is 26. So, this is 26 minus 8 minus 1 is 7d. So, ato na siya ay kana subtract. We have 26 minus, sorry, I forgot d. D here is 4. D here is 4. So, 7 times 4. So, we have minus 28. So, therefore, our a sub 1 is equals to negative number. That is negative 2. So, mo din ay una sa ato ang series, ang negative 2. Since na naman tayo a sub 1, then, we can now use the formula that starts from 1. So, we can now use this. A sub n is equals to a sub 1. Okay, sorry. That is a sub 1 plus n minus 1 times d, and then n starts at 1, 2, 3, 4, and 5. Okay, 5 terms man. So here we have a sub 1 is equals to negative 2. So automatic a sub 2 is equals to negative 2 plus the common difference, 4. So we have here 2. A sub 3 is equals to, pwede po ng a sub 1 nga formula, plus 3 minus 1 is 2 times 4, the difference. So that is 8 minus 2, that is 6. Then a sub 4, that is a sub 1 negative 2 plus n minus 1, 4 minus 1 is 3, times the difference 4. So 12 minus 2, that is 10. Then a sub 5, that is a sub 1 negative 2 plus 5 minus 1, 4 times 4, we have 16 minus 2, that is 14. So therefore our arithmetic series for the first 5 terms is negative 2, then 2, then 6, then 10, and then 14. So this is our kanang answer. Mo siya, class. Okay, so again, don't forget the general term. Magamit na nimo. I mean the general formula day for the arithmetic sequence or series. Okay, so mo siya, class. Let's proceed to the arithmetic series, writing an equation. So diri na pod, writing an equation na pod for our arithmetic series. So here, given taog a sub 1. Okay, nata ay given nga a sub 1 is equals to 15. And then diba, in order to write for the equation, na dapat nimiyari siya a sub n is equals to a sub 1 plus n minus 1 times d. So be sure nga naatay a sub 1, so na naman ta okay na. Dapat na po tay d. Since umatay d atong pangitaon, and then kung makuha ta sa d, then kuha na ta, suwat na ta og kanang equation for the nth term of this arithmetic series. So to solve for D, na second nga given kani siya. So ipasabot niya ni sir. So if we're going to substitute k is equals to 1, that is a sub 2 equal daw siya sa a sub 1 plus 4. So ipasabot na ini. So again, di ba, ang ato arithmetic, kung ato siya tanawon, i-arrange siya pagbalik, that is a sub 1 followed by a sub 2 followed by a sub 3. We all know that the difference of a sub 2 minus a sub 1, that would get us the common difference D. So since na naman tayo a sub 2, so we can now solve for D. That is a sub 2 di is just equal to a sub 1 plus 4 minus a sub 1 is equals to D. So makancel ni siya. What's left is the common difference di is equal to 4. So D is equals to 4. Since we already know D and a sub 1, so therefore to solve for the nth term, this is equal to a sub 1, a sub n is equals to a sub 1 plus n minus 1 times D. So that is a sub n is equals to a sub 1 is 15 plus n minus 1 times the D here is 4. So we can also simplify this. That is 15 plus 4n minus 4. So that would be a sub n is equals to 4n plus 11. Okay, 4n is equals to 4n plus 11. So therefore, this is our formula for our arithmetic series. Kung imo na i-try, makakuha gid ka. Ang ilang common difference is 4 and the first term is 15. Okay, to check this, para mukha dyan mabuto. So at n is equals to 1, that is a sub 1 is equals to 4 times 1 plus 11. So that is equal to 15. So sakto gid siya. Okay, so let's move to the second given. So nata diri nagyapon tayo a sub 1. So same nagyapon. We have a sub 1 is equals to 200. Then let k is equals to 1. So magiging kuan siya. It will now become a sub 2 kani siya a sub 2 equals a sub 1 minus 10. So therefore, the difference here, the common difference for arithmetic, that's just a sub 2 minus a sub 1. So we have here a sub 1 minus 10 minus a sub 1. So therefore, our common difference here is negative 10. So subtraction siya. So writing the general equation for the arithmetic series, that is a sub n is equals to a sub 1 plus n minus 1 times D. Na naman tayo a sub 1, na po tayo D. So substitute, we have 200 plus n minus 1 times negative 10. So pwede po na ito i-simplify. So 200 minus 10n plus 10. So that would be 210 minus 10n. Or we can also factor out 10. That would be 21 minus n. So muna siya to ang a sub n for the second example. Okay, so yan na siya class. Just follow the kanang general equation for the arithmetic series. So here, for letting k here class, you can let any number. K is equals to 1 lang. Kay anyway, same ragid na ang ilang answer class. Kay ang goal na to dira is kuha na ilang common difference. Kaya ang difference ni a sub 2 minus a sub 1 is also equal to, let's say, a sub 3 minus a sub 2. Pareha ra gina sila kay diba sa arithmetic constant ba ang difference. Okay, so next ato na po diri is finding the nth term. Okay, finding the nth term of our arithmetic progression or series. So we have here a sample of arithmetic series. Pangitawon diri ang 20th term daw. So here naatay a sub 1. This is our a sub 1. question diri is asa ang difference. So imo ra i-subtract ang nag-una sa ulahi. So 8 minus 11, the answer here is negative 3. Kung 5 minus 8, that is negative 3. 2 minus 5, negative 3. Negative 1 minus 2, that is negative 3. So arithmetic kini siya with a common difference of negative 3. So if we already have that, then makakuha na ta sa ato ang n, because the given here nga n is equals to 20. So therefore a sub n is equals to a sub 1 plus n minus 1 times d. That is a sub 20 is equals to a sub 1 plus 20 minus 1 times d. So we now have a sub 1 is 11 plus 20 minus 1 is 19. The difference here is negative 3. So therefore our a sub 20 is equals to 11 plus 19 times negative 3. So that is negative 46. So that is the 20th term, negative 46. Negative 46. So mana siya? Muna siya ito ang a sub 20. Second question. So yun dire, if the 10th term is 9, so that is a sub 10, and the 20th term is 49, so we have a sub 20 is equals to 49. What is the 25th term of the progression? So ang pangita is a sub 25. So managin yun, wala na given a sub 1, a sub 2 ug ang common difference. So ang best na is to use the general formula for arithmetic series. That is, we're going to pair muna kaning a sub 10 and a sub 20 to solve for d. To do that, use the general equation. So we have a sub n is equals to a sub k plus n minus k times d, wherein we're going to let from our given, that is n is equals to 20, k is equals to 10. Okay, so that is equal, mahimo ni siya og a sub 20 is equals to a sub 10 plus 20 minus 10 times the d. Solving for d, that is a sub 20 minus a sub 10 all over 20 minus 10 is 10. So a sub 20 is 49 minus 9 all over 10, so that would be equal to 40 all over 10. That is equal to 4. Okay, so therefore ang common difference dai is 4. So to solve for a sub 25, you can there's a lot of kanang solutions here. So ano yung pagkuha? You can base your solution with a sub 20 and 25. Just let k is equal to 20. Or you can use a sub 10 and 25. Just letting k is equal to 10. Or you need to solve a sub 1 na lang para masunog din ito ang first. But very far na kayo taas ng process. So I can just let na lang for values of n and k. So that is at n is equals to 25 and then k is equals to 20 lang ang gamiton with a common difference of 4 sa atong nakuha. So here, general formula, that is a sub n is equals to a sub k plus n minus k times d. So we have here a sub 25 is equals to a sub ni ang k na to kay 20 man, so that is a sub 20 plus 25 minus 20. The difference is 4. So a sub 25 di is equals to, the a sub 20 is 49, so we have 49 plus 25 minus 20 is 5 times 4, so that is 49 plus 20. So q here, the I mean not q, a sub 25 day, that is a sub 25 is equals to 69. So mana siya class ato ang kanang ika 25th nga term, ang kaniyang 69. Okay, so ato i-prove kung same ba sila og kuha kung lahi atong reference. Let's say we're going to refer our k. Again, n gihapon kay 25. But this time, k now is equals to kanina pong a sub 10. That is k is equals to 9. And then d is equals to 4 ang gihapon. Using the general equation, we have a sub 25 is equals to a sub 9 plus 25 minus 9 times the difference of 4. So here, a sub 9, I mean a sub 10 siya. This is a sub 10. A sub 10 is diri a sub 10, so therefore can I see diri this is not 9, kung na sidra 10. 25 minus 10 kay k man. Okay, so a sub k or a sub 10, so diri a sub 10 mo siya. Ang a sub 10 nato is equals to kanang kuan a sub 10 to is 9. Okay, this is 9, so dapat si k diri kay 10 gini siya diri then plus 25 minus 10, we have 15. 15 times 4, so a sub 25 is equals to 15 times 4 plus 9, that is 69. So therefore same lagi hapon 69. Okay, so let's proceed to the next. So we have here finding the arithmetic mean. So sa mga arithmetic series pa rin nga mga problems class, na po yung mga questions nga ipangitaon ninyo ang arithmetic mean. So when we say an arithmetic mean, ang muna siya ang term nga between sa tuha ka given nga mga terms. Let's say we have an arithmetic series 4, 8, then 12, then we have 16. So here, the arithmetic mean between this one, between 12 and 4 is 8. Now, for an arithmetic series, the formula is just simply the mean of the data. Diba? Sa statistics, formula ana is just the mean of the data. So that is, if this is our a sub 1, this is our a sub 2, and this is a sub 3. So the arithmetic mean between a sub 1 and a sub 3 is of course a sub 2. So that would be a sub 2 is just equal to a sub 1 plus a sub 3 divided by 2. So muna siya, mean na siya. And also, if we're going to find the arithmetic mean for 4 and 16, well, it is between 8 and 12. And since that is not included on our series, so therefore the mean there is null for arithmetic series. Because kung kana siya arithmetic mean, it should be part of the arithmetic series. Okay, parte na siya. So therefore, mugana ng arithmetic mean if kanang kuan add ang iyahang pag-solve for or add ang given nga mga terms. That is a sub 1 add number, a sub 3 add number na siya. So di pwede a sub 1 and a sub kanang 4 kay even naman ang a sub 4. Okay, so here we have an example. So ingon diri find out the arithmetic mean between 2 and 6. So simply a sub m pwede pod. A sub m represents the mean. So that is 2 plus 6 divided by 2, so that is 8 divided by 2. The arithmetic mean is 4. Of course, if we're going to write that one, 2, 4, and 6 still follows an arithmetic series because they have a constant common difference of 2. Okay. Next, the second one, find the arithmetic mean daw of 11 and 5. So AM is equals to 11 plus 5 divided by 2, so that is 16, divided by 2, that is 8. So therefore, writing the series, we have 11, then 8, and then 5. So trying to verify whether this is uh, arithmetic series, you can see, so that is 8 minus 11 is negative 3, 5 minus 8 is negative 3. So therefore, they have a constant common difference of negative 3. So indeed, arithmetic series siya. So yung na pag kuha sa arithmetic mean sa atong arithmetic progression or series. Next is we're going to find the sum of an arithmetic series. So the sum of our arithmetic series follows this general formula. So our general formula for the sum of the arithmetic series is S sub n, so denoted by S sub n, is equals to n over 2. Then we have here 2a sub 1 plus n minus 1 times d. So mara na inyo tigaman. Okay? And we also have another kanang definition for this, or another version dia is a sum, since kay ba man ta nga si a sub n is equals to a sub 1 plus n minus 1 times d. So therefore, if we're going to split that to a sub 1 sa given nga sum, mahimo siyang s sub n is equals to n over 2, then a sub 1 plus a sub 1 plus n minus 1 times d. So we all know that this expression is just equal to our a sub n. So therefore, another version for the sum of the arithmetic series is equals to n times a sub 1 plus a sub n all over 2. Yan, let's say if the given is the first term and the last term, and then the number of terms, so you can use this. If na common difference, so you can use the first version. So this is the first version, then second version of our formula for the sum. So start sa first example. So we have find the sum of the first 10 terms of the arithmetic series 10, 6, 2, negative 2. So the first 10 terms lang daw. So we have here a given ta og n is equals to 10 kay 10 terms naman. Given tag a sub 1, that is 10 food. Then of course what ay a sub n, but you can also solve for a sub n, but it's a long process. Ang pinaka shorter one is just look for the common difference. So the common difference is just take the difference of the next term by the previous. So 6 minus 10 is negative 4, so d is negative 4. So here natay given nga n, a sub 1 and 4 d. So we can use the first version of our formula for the sum. So we have here s sub n is equals to n over 2 times 2a sub 1 plus n minus 1 times d. So n here is 10 divided by 2, then 2 times 10, n here is 10 minus 1, 9 times 4. So we have here 5, 2 times 10 is 20, plus 9 times 4. That would be 5, 20 plus 36. That would be equal to 5 times 20 plus 36. We have 56. So 5 times 56, 0, 3, 25, 28. Okay, 28. So 280 day ang sum niya. So kaya mo na mano-mano mo 280 gani siya. Okay, so kung gusto ka magamit sa second version, you need to find first the a sub n, but it's a long process, so duha na ka kanang solution imo magamit. But anyways, both of the process or the solution still arrive the same answer. Okay, so proceed ta sa second example. Nata diri find the sum of the integers between 89 and 100. So between 89 and 100 and 200 So when we say between 89 and 200 are not included. So therefore, we are going to start, that is a sub 1 starts with 90. Then hanggang 199, diba? That is our a sub n is equals to kanang 90, 199. Okay, so we don't have, we all know the common difference here because integers man ito. So integers is a whole number. That is 1, 2, 3. So therefore, a common difference sa whole numbers is 1. But there's a simplest way to solve for this. Since here, we all know that the number of terms here, diba, between 90 and 99, that is the number of terms n is just equal to the difference of 199 minus 90 then plus 1. Okay, nganong plus 1 man, sir? So let's say nganon siya, if you have a list of terms, that is, let's say 1, 2, 3, 4, and 5. Now if we're going to take the difference of 5 and 1, the result is 4. Now 4 does not does not kanang tell yet the number of terms here. Kay kung imo ipon jud sa tagsa, this is 1, 2, 3, 4, 5 5 man. So dapat kung ano mo process, imo gyud siyang adan og usa to make it 5. So therefore same din sa toy battery, since si 199 and si 90 ka included, so therefore ato siya adan og 1 after nila mag-subtract. So that is n is equals to 199 minus 90 plus 1. So the result is the number of terms sa ato ang arithmetic series. So 199 minus 90 plus 1, that is 110. So 110. So here, given ta a sub 1, given ta a sub n, given ta ni n, so we can use the second version of our formula for the sum. That is s sub n is equals to n times a sub 1 plus a sub n all over 2. So this would now become 110 times 90 plus 199 all over 2. So that is equal to 110 times 90 plus 199 all over 2. So the answer is 15,000. So 15,895. So that is the sum. Actually, you can check that one by using the first version, wherein ang d na to is equals to kanang 1. Kay common difference niya ng integers kay equal to 1 man. Okay, so let's try para ato ma-prove. So that is s sub n is equals to n here is 110 divided by 2 times 2 times 90, then plus 110 minus 1, so that is kana 109. The difference is 1. So that is 110 divided by 2 times 2 times 90 is 180 plus 109. So the result is 15,895. So same ra gyapon, 15,895. So kanang kuan, both formulas arrive the same answer. So it's up to you kung asa mo pilion ug asa mas dali para nimo. Next is we have here an application for an arithmetic series. So kani siya kung gipili kanindot na siya nga application sa arithmetic series. So let's say we have here a frog daw is trapped in a 25 meter nga well. So let's say mano siya tong well, laom kaayo. So the depth of the well is 25 meters. Of course, das ubos na ibaki. Okay, let's say this is a frog. Then every minute it jumps 3 meters and slips back 2 meters. So let's say maka-jump siya og kanang kuan 3 meters. Moubos pud siya og 2 meters. So therefore ang iyang displacement ra gyud niani iya rang nairog is 1 meter ra gyud kada ambak kay mahugman siya. Okay? So iyan ay buhaton hantod nga ma-reach niya ang top sa well. Okay? So ingon dire, after how many jumps daw will it reach the top of the well? Okay? Given nga 25 ang gitason sa well. So here, since this is the displacement, if we're going to add, okay, the number of times, if we're going to add the displacement of the frog for every jump, that pertains to the sum sa iyang displacement. And kung imo na i-add, it will equal to the height or the depth of this kanang well kung asa siya na-trap. So therefore, we can use the S sub n, that is the summation or the sum of the arithmetic sequence. Okay, so that is ato siya i-kuan nga i-let na to mga given. So we have here S sub n is equals to 25 meters. And then ang ato ang A sub 1, that is aya ang first nga pag-jump, that is 1 meter. Unya ang sunod na pod mo jump na po siya utro og 3 mo balik og kanang kaduha, so same na gyapon 1 meter. So therefore atong d niini, d is equals to 1. That is the common difference. Okay, that is the common difference. So next, what we need to do is to solve for n. So we're going to solve for n here. So bahaton na to ani S sub n is equals to kanang kuan n all over 2 times 2a sub 1 plus n minus 1 times the difference of 1. So therefore that is 25 is equals to n over 2 times a sub 1 is 1, so 2 plus n minus 1. So that would be 25 is equals to n over 2 times n plus 1 lang ni. So here, we're going to multiply both sides by 2. So we have 50 is equals to n times n plus 1. So here, quadratic ang makuha niini. So we have 50 is equals to n squared plus n. So that is n squared plus n minus 50 is equals to kanang 0. So solving for the value of n here, so that is n to equal diri as, so we have mode equation quadratic, alpha is 1, beta is 1, c is negative 50, this is negative 50. So we have here kuan siya 6.58. So ato ikuan diri 6.58. So na siya point 6.58, and then n2 is negative 7.59. Well, ato siya i-ignore. Okay, ato siya i-ignore. Okay, so let's continue. So kana siya, ang pag-model nga problem is di na siya ma-apply aning kanang summation. So since ang pasabot aning kaning depth sa kanay ang well, kung asa ang pakinahog is kani siya mo na siya may pertain sa kanang a sub n. Okay, this is our a sub n, meaning sa pagkabak niya mo na ang iyang kanang distance nga na accumulate. case kay kung ato siya i-trace up, ato siya i-trace up ang baki, let's say sa first niya pag jump, that is a sub 1, that is equals to 1 meter ang effective, since may jump siya 3 meters high, then may slip siya og 2, then a sub 2 is, that is 1 plus 3, 4, slip og 2, so 2 na lang. Then a sub 3 is equals to 2 plus 3 is 5 minus 2 is 3, so on and so forth hanggang makabot siya ni a sub n is equals to 25 meters. So ato ipangita si n ira. So solving for n, that is a sub n is equals to a sub 1 plus n minus 1 times d. We all know that the common difference here is just equal to 1. So that would be a sub n is 25 is equals to a sub 1 is 1 plus n minus 1. D here is 1. So therefore we have 1 plus n minus 1. So maka-cancel ni siya. Cancel ni. So here n is equals to 25. So naiuban ninyo mingon og n is equals to 25. However, if we're going to analyze this in reality, okay, so pag abot manggod niya og, let's say makabot siya og kanang let's say makaambak siya og 20 times, or let's say iga 22, okay, so pag abot niya og 22, okay, pagka 22 niya, kaya diba, let's say if na-complete na niya ang 21, pag complete niya ang 21, the remaining lang is pila, diba, 25 man eh ang sukod ani, overall this is 25 meters. Since linear man ang ang pag-usad niya, so at the 21 nga or I mean 21st or kana siya 22nd, pagka 21st ang nabili na lang diri nga height kay 4 meters. Okay, so in real life kung maambak siya 3 meters di ba siya kaabot, mo slip siya mo lang mo 4 meters, slip og 2, so we have 22nd. However, at the 22nd na nga jump, okay, this is 21st, pag 22nd nga jump, since the remaining here is already 3 meters na lang class, pag ambak sa bakera, since that is 3 meters, so therefore di na siya ma-slip, meaning nakagawas na siya, so naka-escape na siya. So di ingon nga ang number of times siya para magagawa siya sa is 25. Well, mathematically 25 siya. However, kung mo siya i-analyze in real life, the actual times nga mo jump ang frog is just equal to n is equals to 22, meaning ka 22 times siya, or at 22nd nga jump. So again, this is a kanang tricky ni siya nga application sa arithmetic series. So dapat imo pod i-interpret siya in real life. So next, binomial expansion na ta. So kumintag binomial expansion, from the word itself, binomial man siya, no. So composed ni siya of kanang two terms. So let's say we have binomial expansion x plus y, then i-raise na siya into a certain exponent n. So if we have here x plus y raised to the power of 2, the expansion is x squared plus 2xy plus y squared. So here, I think ato na discuss sa ato ang previous nga module ang pag-determine sa mga coefficients nila, as you notice, kaning coefficient din ni x squared, kaning coefficient ni xy, o kaning kang y squared, ma-determine ni siya by analyzing or by looking at the Pascal's triangle. So, diba kay Pascal's triangle, that is if we have 1, then 1, 1, then 1 na po diri, then i-add yung 1 plus 1, 2, suwat kag 1, suwat na po kag 1, i-add ni dira 3, then 3, 1, then next 1 na po, i-add na po 4, this is 6, then 4, 1. Kaning Pascal kanang triangle, manas po siya nag-denote sa coefficient sa atong expansion. That is, if we're given a binomial term, gi-raise na to exponent, pasabot aning 1, this is x plus y raised to 0. Nga naman, any number is to 0, the answer is 1. So that's why we have 1. Kanang x plus y raised to 1, the answer is 1, 1. That is x plus y lang. So that is, the first term is 1 iyang coefficient, the second term is 1. The next is x plus y squared. So that's why natay 1 to 1. Base akong gi-expand diri That is 1 to 1. Kani po diri x plus y cube. The coefficient niya is 1, 3, 3, 1. Okay, if you're going to simplify this, mana siya ang iyang coefficient. Now, naay shortcut nga pamaagi niini in order to determine the coefficient. So, mara na inyo hang tigamaan. So, if we have, let's say, x plus y cube, kung inyo napansin sa ato expansion class, if we're going to add the class, the exponent for the variables in a certain term, the result is equal to the exponent nga gi-raise siya. So here, gi-raise siya og square. Gi-raise siya og square, so automatic square po di diri So the x1, y1, i-add nimo 2 gihapon. So y squared gihapon. So that is for every term na conserve ang iyahang number of exponents or the value of the exponent. So automatic pag expand aning kuan class x and y, automatic mag-una ka ni x cube, so meaning partira na siya y raised to 0 para 3 plus 0 is 0, then followed by x squared, so meaning kung si cube padako mo gamay, si y pagamay mo dako, so that is x squared, y 1 na siya, plus x na lang, then y squared para 3 gihapon, then plus x raised to 0 y cube. So automatic, the leading term should have a coefficient of 1. Nagina siya 1 dira or invisible na lang. Alay, so what? Then to solve for the next coefficient diri just follow this formula. That is the exponent of the x on the previous, ato denote as a, then multiplied by the coefficient b of the previous, that is 1, all over the coefficient of y plus 1. Cy na lang. Rato ay otro. Again, muna siya ang dali para di na kayo mag-expand yun. So, atotroon to, that is the exponent of x. So, that is exponent of x multiplied by the kanang coefficient of the previous. So, mao na yung previous, kaya mao na to ang ipangita kani. So, previous niya is kani siya. So, that is the coefficient of the previous divide by the exponent na pod ni y sa previous ni siya, sa mga previous ni, plus 1. Mara yung matigaman. Kung ato na i-apply, so to solve for this next term, that is the exponent of the x on the previous, that is 3, diba? That is 3 multiplied by the coefficient of the previous, that is 1, divide by the exponent of y sa previous, that is 0, then plus 1. So that is 3 times 1 is 3, divide by 1, the answer is 3. So therefore 3 ni siya. That's why we have 3 here. So diba, misakto for x cubed. Next, diri na pod. Summary diri So here, ang imo na pong previous is kanina pod. Ano po na yung previous? That is the exponent of the x on the previous is 2 na pod. Diba? 2 na pod diri. That is 2 times the coefficient na pod sa previous. Since man siya previous, ang coefficient kay 3. So multiply na mo 3. Divide by the exponent of y here sa previous. That is 1 na siya. 1 plus the constant 1. So that is 2 times 3 is 6. Divide by 2, the answer is 3. So that's why we're going to put here 3. So mo nang 3 po diri Next, sa last term, kani siya diri So shortcut. Ang previous na pod kay kanina pod. So that is the exponent of the previous is ang x diri, exponent kay 1. So 1 multiplied by the coefficient of the previous is 3 divided by the exponent of the y sa previous is 2 ni siya. Then add a constant 1. So we have 3 divided by 3. The answer here is 1. So that's why natay 1 dira. So sakto gid siya diri nga 1. So ingon na siya class, ingon na pag simplify sa iya coefficient. So if naay value imong x ug y, so that is now the time nga imo na siya simplify further. So we can also use this shortcut method to solve for to verify this one kaning x plus y raised to the power of 4. So again, before doing this shortcut method, kailangan naka-arrange sa mga exponents. So that is starts with x to the 4th, then y 0 plus x cubed, y 1 plus x squared, y squared plus x y cubed, then plus x0 y to the 4th. So again, ang automatic coefficient sa leading term is 1. So solving for the coefficient here. So consider this as your previous term. So to solve for this, that is the coefficient of your x on the previous, that is 4 multiplied by the exponent there multiplied by the coefficient na pod sa previous one divided by the coefficient of y sa previous 0 plus the constant 1. So that is 4 times 1 divided by 1 is 4. So 4 ni siya. That's why na type 4 po dira. Next, diri na pud ta sa ikatulo nga term. So that is the coefficient, the exponent of x on the previous. So mo na po itong previous. So 3 multiplied by the coefficient sa previous, that is 4 divided by the coefficient of the exponent of y sa previous, that is 1 plus 1. So we have here 12 all over 2, that is equals to 6. So 6 ni siya. That's why nabatay 6 area. So diba? Next, diri siya. So kanina pod may mahimong previous. So to solve for this, so natay exponent sa x sa previous, so that is 2 multiplied by the coefficient of the previous, that is 6 divided by the coefficient, the exponent of y sa previous, that is 2 plus the constant 1. So that is 12 divided by 2, 3 di, that is equals to 4. So that's why 4 ni siya. So ato po makita 4. Next, the last one kani diri so kung kanina po imong isolve, mo na po imong previous. So here kini siya the the exponent of the x sa previous, that is 1 multiplied by the coefficient of the previous, that is 4 divided by the exponent of the y sa previous, that is 3 plus 1 the constant, so that is 4 plus over 4, that is equals to 1. So that's why 1 na siya diri so mo na nalay 1. So ina na to class, gamit lang tani nga shortcut to expand binomial expression. So applying that one sa ato ang given. So to siya erase. I hope inyo nang gi-note. So we have here y minus 4 cube. So pwede po ka mag-let para di ka maglibog. So imay kandere let a is equals to y, b is equals to negative 4. So that a plus b cube is equal to, so kato na ta, mahimo ni siya og kanang a cube b0 plus kani siya, this is a squared b1 plus a b squared plus a0 b cube. So again, ato to i-follow to ato ang shortcut method. So to solve for the coefficient of the next, so we all know that the coefficient here is a cube na lang. Ato na i-neglect ning b. Plus, to solve for the coefficient of the second term, again, that is the exponent of a, the previous, multiplied by the coefficient sa previous, divided by the exponent of b plus 1. So na to a squared b squared din plus, ato na i-simplify. Simplifying this, 3 times 1, 3, divide by 1, so 3 gihapon. So this one right here is 3. Next, diri na pod, if mo na po itong pangitaon, mo na po itong previous. So exponent sa a sa previous is 2 times the coefficient here is 3 na kanito na solve. So 3 divided by the exponent here is 2 plus 1. Then a b squared. And we'll know that 2 times 3 is 6 divided by 2 is 3. So therefore 3 gihapon na siya. The next is the last term. So we have plus, kung mo na ito na i-solve, mo na po na itong previous. So the exponent of a there is 1 times the coefficient now here is 3 divided by the exponent of the b sa previous, that is 2 plus the constant 1, then a to 0. So ato na i-neglect ng a to 0, b cube na lang dayon. So we have here b cube. So simplifying that one, 3 times 1 is 3, divided by 2 plus 1, 3. So the answer is 1. So therefore b cube lang po natira. So substituting a, so a is y, that is y cube plus 3 times a is y, then squared. Ang b na to is negative 4, b4 squared plus 3 times a is y, b is negative 4 squared plus b is negative 4, then cube. Simplifying further, we have y cube plus 4 squared is positive 16 times 3 na may 3 nga constant. So ang kuha na niya 48. So plus 48y squared, diri gi-squared na pod. Diri si a 1 pa ni siya, sorry. Kani siya 1 pa ni. Sa erase. Kani siya diri 1 pa ni siya dapat, kay nag-start siya sa 0. So this 1 pa lang. So 1 pa lang ni siya diri So that is negative. So negative din siya diri This is minus kay 12 man. That is minus 12 y squared. The next, negative 4 squared, 16 times 3, 48. So manan siya ang positive plus 48 niya, y na lang. Then 4 cube, that is minus 64. Minus 64. So that is our expansion for y minus 4 cube. So inganaw na class pag-expand. Okay. So next proceed ta sa kaduha. So same ra itong buhaton. Mag-let na lang budta. So let a is equals to 1 over x, b is equals to y. So that is a plus b raised to 5. Ito i-arrange, that is a to the 5 b0 plus a to the 4 b1 plus a cube b2 plus a squared b3 plus a b4 plus a0 b5. So ato isolve iyang mga kanang kuan, iyang mga coefficients to shortcut method. So automatic 1 na iyang coefficient. Diri 1 itong previous na pod. So exponent sa x sa previous 5 times the coefficient here is 1 divided by the exponent sa b sa previous 0 plus the constant 1, then a to the 4th b. So here, ang iyahang simplification, 5 times 1 divided by 5, the answer here is 5. Next, proceed. Plus, muna po ni ato previous. Kaya muna po ni atong pangitaon ng coefficient sa a cube b squared. So that is the coefficient of x, exponent sa x, sa a, sa previous, that is 4, times the coefficient of the previous, that is 5, divide by the exponent of b sa previous, that is 1, plus the constant 1, then a cube b squared. So simplifying that one, 5 times 4, 20, divide by 1 plus 1, 2. So that is 10. So 10 is here. Then next, plus the coefficient, the exponent of the previous, muna po na yung previous na to, of a is 3 times the coefficient 10 divided by the exponent of b sa previous, that is 2, plus the constant 1, then this is for a squared b cubed. Okay, then ato na i-simplify. 3 times 10 is 30, 2 plus 1 is 3, 30 divided by 3, that is 15. 30 divided by 3, that is kanang 10. So ato erase 10 din siya diri. So next, muna po natong previous atong pangitaon si ab to the 4th. So the exponent of a sa previous 2 times the coefficient 10 divide by the exponent of b sa previous, that is 3, plus the constant 1. So this is for ab to the 4th. Okay, so mahimo ni siya diri og katong simplify. 2 times 10, 20, plus divided by 3 plus 1, 4. 20 divided by 4 is 5. So mahimo siya diri og 5. Then lastly, mao na po na siya atong himuog previous to solve for the next, or for the last. That is the exponent of a sa previous, this is 1, times the coefficient 5 divided by the exponent of b sa previous, that is 4 plus 1. This is b to the 5th. So ato na siya i-simplify. 1 times 5 divided by 4 plus 1, 5, that is equal to 1. So this would now be equal to 1. So here, naanatay expansion nga a to the 5th plus 5a to the 4b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4th plus b to the 5th. So substituting the values of a and b to get the final answer, so we have 1 over x raised to 5 plus 5 times 1 over x raised to 4 times b is y plus 10 times 1 over x raised to 3, then b is y squared plus 10 times 1 over x raised to 2, then y cube plus 5 times 1 over x. P is y to the 4th plus y to the 5th. So simplifying, we have 1 over x to the 5 plus may na siya og 5y all over x to the 4th plus kanya siya siyang 10 y squared x cubed plus 10 y cubed x squared plus 5y to the 4th x plus y to the 5th. So, mano siyang expansion for 1 over x plus y raised to the 5th power. So, ino na ito pag-expand class. Okay, so, proceed sa next. What if, di ba kay taas man kay pag-expand. So, what if gusto lang ta makaibaw class sa katong ika 4th term or ika 3rd or ika 5th term sa ato expansion. What if ganahan ta makaibaw ni ato dili ingon nga ang tanan gyud nga terms to ilista. So, napud tay anay formula. So, diri sa atong next example is we're going to find the art term. Okay? Or here sa akong example, gi-abibit siya as n. So, that is find this one, n is equals to 4, meaning this is the 4th term. N is equals to 9, this is the 9th term. So, to solve for the nth term, just follow this formula for binomial expansion. That is, for the coefficient, use the combination ng formula. Actually, gikan ni siya sa statistics. So, that is NC R minus 1. Then, for your x, let's say, or ang imong binomial kay in the form a plus b raised to, let's say, n. So, that is for a, i-raise na nimo ang a to the coefficient n minus r plus 1. Then, ang yung b, r minus 1. Kay, kung imo na siya i-add ang exponent ni a and b, ang result kay equal to n. So, now, preserve gihapon ang ato ang exponent for the binomial. So, kani siya din nga formula. Mo na siya nag-determine sa ato ang coefficient for the expansion. However, if napakay coefficient for a and b, of course, kailangan sa nimo i-multiply aning atong general coefficient. So, mo na siya. So, here, ato pangitaon. So, ato ni ilet, palit ang libog, diri, ato ni ilet nga r ni siya. This is r. Kay, ang first ato nga given, so, the first given, we have here n is equals to 10, meaning that is the exponent of the binomial expansion. So, following this, again, kanin siya, this is formula for the combination. Kani combination nga formula sa statistics. Combination. Kaya ang pattern magud sa atong Pascal's triangles for binomial expansion, follow ni siya aning combination nga rule. So that is n cr minus 1. This is equal to n factorial all over n minus r plus 1 factorial, then r minus 1 factorial. So, wala siya, gamit gyapon ang factorial nga expression. So, you can manually solve this or you can just use your calculator. Naman siyang NCR minus 1. You can do combination sa imong calculator. So, here, our first problem is to look for the 4th term. So, solution here, since naman tayo n over value, so that is kung ano siya, NCR minus 1 Then si A matches with X and B matches with Y. So just put X n minus R plus 1. Then Y raised to R minus 1. So our n is 10. So that is 10 combination of R is 4 minus 1. That is 3. Then our X here is 10 minus 4. 6 plus 1 is 7. Then Y raised to R is 4 minus 1, that is 3. So kung imo mapansin, 7 plus 3 is 10. So na-conserve gihapon. Then 10 combination 3, this is just equal to 10 factorial all over 10 minus 3 factorial, then 3 factorial. So we have x7 y cube. So ang 10 factorial, reducing this, so 10 factorial all over 10 minus 3, that is 7 factorial, then 3 factorial. Actually, ang 10 factorial can be written as 10 times 9 times 8 times 7 factorial. Kaya 7 factorial is 6, 5, 40 through 1. So 7 factorial times 3 factorial. So natay makancel na ini kanisiya. 7 factorial, 7 factorial. And this 3 factorial can also be expanded into 3 times 2 times 1, diba? Mission 3 times 2 times 1, so that 9 and 3 natay makuha, makancel out. Kani siya 9 and 3, so this would be 3 na lang. Kay 3 times 3 is 9. 2 and 8 naatay 4. So therefore, nabilin sa numerator is 10 times 3, 30 times 4, 120. Therefore, our final answer here is 120 x to the 7 y cube. So this is the fourth term of our binomial expansion. Mana siya. So ay kalimtan ni nga formula ncr minus 1 a raised to n minus r plus 1 r minus 1. So the reason why na ay r minus 1 because diba if we raise the binomial expression by power of 3, ang iyang number of terms kay manobrag usa. Okay, kay diba sa binomial gi-raise to the power of 2, the result is a trinomial instead of 2. So that's why nag-subtract butag 1 diri para matakdo ta sa ika-fourth nga term. So second example, given ang r 9, given po ng n diri, that is the exponent 12. So therefore, follow the formula ncr minus 1. Then here, we let ato ilet para di ta maglibog. We let a is equals to 10x, b is equals to negative 3y. So that would be ncr, then a raised to n minus r plus 1, b r minus 1. And here is 12, so we have 12c, r is 9 minus 1 is 8. Then our a raised to 12 minus 9, that is 3 plus 1, 4. Then b is 9 minus 1, that is 8, because 8 plus 4 is 12. So sakto ra. Next, simplifying this combination ng expression. So we have 12 factorial all over 12 minus 8 is 4 factorial, then 8 factorial. So 12 can be written as 12 times 11 times 10 times 9 times 8 factorial all over ang 4 factorial can be 4 times 3 times 2 times 1 times the 8 factorial. So na makancel ani si 8 factorial. Then ang 4 og 12, so natay 3. Ang 3 og 9 natay 3 mabilin diri, ang 2 og 10 natay 5. So therefore we have 11 times 3 times 5 times 3. So that would result to natay 3 times 11 times 5 times 3. So natay 495. So we have here 495, then a to the fourth, b to the 8th. Since we have values for a and b, so ato pud na siya apilon. So we have 495, a is 10, x raised to the power of 4, b is negative 3y raised to the power of 8. So automatic kaning si negative 3 kung i-raise sa 8, positive kay even man ni siya. So therefore, may siyang 495 multiplied by 10 raised to the power of 4, x to the fourth. I mean, ato pa rin na ikumbaning usa ka constant, ang negative 3. So we have here negative 3 raised to 8. So natay x to the fourth, y to the 8. So simplifying that one, we have 495 times 10 raised to the power of 4 times negative 3 ni siya. So negative 3 raised to the power of 8. So dako kani siya. So we have here 3.25 approximately times 10 to the power of 10 siya. Okay, so x to the 4, y to the 8. So that is our final answer. That is the 9th term. Okay, mana siya ang 9th term sa ato ang binomial expansion. Okay, just follow na lang sa formula. Next, dito sa ato ang kanang final topic. So diri ato na pod i-find ang term nga nalan siya nag-involve man siya x raised to r, meaning na siya coefficient, I mean variable gi-raised to a certain raised to a certain exponent, maybe 5 or any integer. So here atong gipangitaan ni is term nga nag-contain siya og kani siya x to the 5. So that is ang ato ng r diri kay sa to given r is equals to 5. Kay x raised to r man diri, containing x raised to r da, so mana siya. And then our n is equals to 12. So normally class, r should be less than n. R should be less than n. We can use the formula. Here, ang formula na po ani is not from, I mean, kan siya, dissimilar siya from the previous. Because in the previous, di ba, ang forma adto is ncr minus 1 x raised to n minus r plus 1 then y raised to r. Here, the formula kung gana na ka mo find og term nga na siya nag-involve siya x raised to r, meaning no need to minus or no need to subtract the exponent by 1. Here, largo nag n cr then x raised to n minus r then y raised to r. Because here, it's either x or y nag-involve siya sa term nga r. Okay, so we're going to use this second kana siya instead of the first. So din na siya. So applying that one, so it is applying this. So namatay given nga n and r. So n here is 12, so we have here 12 cr na to is 5. Then our x here is x na lang pod. So x raised to 12 minus 5, that is 7. Our y is 3 man, so that is 3. Then raised to r, that is 5. So that 7 plus 5 still 12. Next, simplify this combination. So we have here 12 factorial all over n minus r. So that is 12 minus 5 is 7. So that will be 7 factorial, 5 factorial. So 12 can be written as, I mean, pwede pa ni-simplify daan. 3 raised to 5 is 3 raised to 5 equal na siya sa 243. So this is 243 x raised to 7. Okay, so dapat di ay diri para we can get x raised to 5, kailangan bali siya. Ang pasabot nini is that since x man is sa first term, so dapat siya diri maoy i-r na to diri ah. Okay? Dapat siya may r na to diri ah. So baliktad na siya because na 7 naman ni diri ah. Okay, so ato to balikon gani ha. So since x to the 5 man siya, from our general formula, NCR x raised to n minus r, then 3 raised to r na siya, diba? 3 raised to r. So since ang ato x should be equal to 5, so we're going to equate the this n minus r to 5 and solve for r. Since we don't have r here, we cannot say that r is equals to 5. Di na siya mao di. Okay, so kailangan sa n minus r mo match siya sa 5. So, and then solving for r para ma-apply na to ang general nga formula. So here, ato pangitaon, so this would be n minus r is equals to 5. Dapat ang exponent sa x dira should be equal to 5. So we all know that n is equals to 12. So solving for r, that is r is equals to n minus 5. R is equals to 12 minus 5, that is r is equals to 7. So mo na siya atong i-substitute dira sa ato ang formula. So that is n is 12, C7, x raised to n is 12 minus 7, that is 5, then 3 raised to 7. So here 12 factorial all over 12 minus 7 is 5, so we have 5 factorial, then 7 factorial. Then x raised to 5 multiplied by 3 raised to 7, so 3 raised to 7, the answer is 2187. So 2187. So simplifying this factorial notation, so we can have 12 times 11 times 10 times 9 times 8 times 7 i-factorial na nato kay taas naman. Well, naman po yung makancel, so we have 5 factorial is 5 times 4 times 3 times 2 times 1 times 7 factorial. So here na makancel, 7 factorial makancel. So kaning 5 ako i-pair sa 10, so mat 2 na ni diri. Ang 3 sa 9 mat 3 ni. Ang 2 sa 8, so that I have here 4 na lang. Then ang 4 sa 12, so that I have here 3. So nabilin is 3 times 11 times 2 times 3 times 4. Sa denominator kay 1 na lang. So ang simplified niya na form is 3 times 11 times 2 times 3, 6 times 4, 24. So that is 792. So we have here 792 multiplied by 2187 x raised to 5. So kung ato na siya i-kuan, ato na siya i-simplify, may mong 792 times 2187, the answer is 1 million. So daw kay siya, so we have 1 million, then 732, then we have 104 x raised to 5. So mana siya class. That is our answer. That is the term involving x raised to 5. Okay, so let's proceed to the last example. Diri po dingin siya nga find the term that contains x raised to 26 in the expansion x negative 2 plus x cubed raised to 12. So we can assure that our n is equals to 12. And we cannot say that 26 is the r, since diba ko r should be less than n. 26 is greater than 12, so that is not the r. Ato mapangitaon si r. So in solving for r, we need to simplify first our given binomial nga term. So here, ang given, kaya naman siya negative exponent, we need to eliminate them. Kasi sa general formula sa binomial, wala negative exponent. So to do that, that would be 1 over x squared plus x cubed raised to 12. Divide both sides, we have x squared, then 1 plus x to the 5th na lang ni. Raised by 12. So ang denominator, monomial naman siya, so we can factor that one. May mo siyang 1 over x raised to 2 times 12 is 24. Then x to the 5th plus 1 raised to the power of 12. So here class, more than atong binomial. Kani. Ato na siya expand. However, for every expansion of this, every term of this should be divided by this. Okay? So therefore, if we're going to use the formula NCR, the x here should be x to the 5th, diba? Then n minus r, then 1, kay 1 man na diri raised to r. Now, since yung mata nga, every term aning expansion kay divided by this x raised to 24, so ito po siya over diri og x raised to 24. So, constant siya kada term, x raised to 24. So, here, kailangan ang resulting x nato, since namatay x sa numerator and the denominator, the resulting should be equal to x raised to 26. So, therefore, by applying the rules of algebra to solve for r, so, solving for ato ra kanang manipulate ang ilang exponents, diba? Exponent sa x sa numerator is 5 times n minus r, sa denominator is 24. I-subtract sila, mo result og 26 dapat. So, mahimo na ni og mahimo ni siya diri og kuan. Mahimo na diri og 5 times n minus r minus sa denominator nga 24 should be equal to 26. We'll know that n is equal to 12. So we have 5 times 12 minus r minus 24 is equals to 26. This would be 60 minus 5r minus 24 is equals to 26. So 5r should be equal to 60 minus 24 minus 26. So 5r is 10 siya. 60 minus 24 minus 26 is 10. Divide by 5. Therefore, our r should be equal to 2. So, mara na ato ang value sa r. Then, substitute that to our equation. So, we now have n is 12. CR is 2. So, again, r should be less than n. So, sakto na 2. Then, x raised to 5. N is 12 minus r nga 2. That is 10. So, 10. Then, 1 raised to r is 2. Divide by x to the 24. So, this 12c2, may mo na siya o ganang 12 factorial all over 12 minus 2 is 10 factorial. Then, 2 factorial. Kani siya, this is x to the 50 all over x to the 24. So, here, ang 12 can be written as 12 times 11 times 10 factorial all over 10 factorial times 2 factorial or 2 times 1. Then x, 50 minus 24, that is x raised to 26 na lang na, diba? X raised to 26. So, kani siya, makancel ni, kani. So, ang 2, this is 6. So, 6 times 11 na. So, therefore, mahimo ni og 66, then x raised to 26. So, therefore, that is our final answer. So, 66x raised to 26. So, ito nakita, that is the 26th term. Okay, so yung naman pag-solve sa itong binomial expansion in finding the term that involves x raised to a certain exponent. So, kailangan ang kanang exponent, di din na mo inyong himuog ha, r. In some cases, pwede po na siya may mong r, but it depends upon the given yun. So here imo jud i-analyze nga the x here should be equal to 5. So manang kaning n minus r akon siyang gilet is equals to 5 then solving for r. Okay? Even if ang 5 kung mo siya i-consider as r that is less than 12, however, this is the real answer yun ani. R should be equal to 7. Okay? Kay kaganiha, kung ato ni si r equal to 7, I mean 5, the result for x here is 12 minus 5, that is 7. So, x raised to 7 na, which is kanang lahi sa ato ang required nga x raised to 5 dapat. So, the same thing with here, akong gisyon ninyo nga x raised to 26. So, 26 is very large compared sa 12 nga n. So, that's why we need to find a way to solve for r. So, ato siya gi-modify ni siya nga binomial expansion nga given since nag-involve ba siya negative exponent. So, kailangan siya nato i-convert into a positive exponent. So, mara siyang nanay atong gi-derive. Then, gisolve na po ito ang r. So, we have here 66 x raised to the power of 26. So, thank you for listening, and that would be all for series, arithmetic, and binomial expansion.